All right, this is just an abbreviated version of the lecture on measures of central tendency and measures of variability. We discussed three measures of central tendency: the mean, the median, and the mode. First, the mean. This is the average. This is the most familiar one. You've computed it plenty in Excel already. This is symbolized by x bar for the sample mean. Of course, the population mean is a parameter, so that's symbolized by the Greek letter mu. This is the sum of all values divided by the number of values that you have. If you have an n, a sample size of 5, then you add up all those numbers and then divide by 5. Okay. The median is, it's not really through a formula. You order your data from least to greatest, and then you find the middle value. Think like the median in a freeway. If there are an even number of values, and so the middle is actually just a gap, then you take the middle two values and compute the average of those two, and that gives you the median. The mode is a measure of central tendency that isn't used super commonly, but it's important to know about as well. It's the peak in a histogram. If you're visualizing your data with a histogram, it's where the peak is. If there are multiple non-adjacent peaks, then it's good to report all of the modes. A bimodal distribution is an example of a distribution with two modes, two peaks. So yeah, this is the most commonly occurring value in your data set. One topic related to the pros and cons of each one is that the mean is influenced by extreme values. So if you have a symmetrical distribution, then the mean, median, and the mode are all the same. However, if you have one side that has some extreme values, if you've got a skew, then the mean gets pulled towards that tail. You can think of the analogy of, or the example of, if you have a bunch of people in a room and you compute their average wealth, you'll get some number. If then you have Elon Musk enter the room and then you recompute the average, suddenly you're going to get a very inflated number that's not really going to represent the central tendency of those data. Okay, so the mean gets pulled up. The median, however, is not going to be influenced hardly at all. Okay, so that's one advantage of the median. It is resistant to the influence of extreme values. One way that you can remember this, mean tigers chase tails. The mean gets pulled towards the tail if you have a skew. Okay, some other pros and cons. The mean is widely used. It's a very familiar measure for a lot of people. It's easier to put into other equations. It's got a more straightforward formula. The median, again, just there's kind of a formula, but it really just tells you the position that you look at rather than how it's actually computed. Medians tend to vary a lot from sample to sample, so it's harder to infer the median of the population from the median of a sample, but the mean of a sample is more likely to represent the mean of the population. So pretty much all of the most common statistical tests are done on means. There are some tests that are done on medians. But yes, a disadvantage is that the mean, is influenced by extreme values, whereas the median is not. One solution to this is that you can use a trimmed mean. So this is where you trim off the tails of your data. You order the data least to greatest, and then you remove the highest values and the lowest values. You'll see on lab assignments or on exams, I'll ask you to do a trimmed mean. If I ask you for the 10% trimmed mean, that actually means that you're removing 20% of the data total. Like if you have an n of 50, a 10% trimmed mean entails calculating the mean after you remove the 5 largest and the 5 smallest values. Okay, so you're actually removing 10 values total, which is 20%, but it's 10% on either side. Okay. So in Excel, you'd sort your data least to greatest, and then you'd take off the top 5 and the bottom 5, and then you'd compute the average after you do that. Okay. There is a trim mean function in Excel, but don't use it. It uses there are actually two conventions for doing the trimmed mean. One is the one that I just explained. The other is that 10% actually means 10% total, so that means trimming off 5% on either side, and that's what the trim mean function does in Excel. But that doesn't align with your textbook. that uses the other convention, so just stick with as it's explained here. Okay. So, for example, the 10% trimmed mean here, the mean of these data is 5.5. 10% trimmed mean is also 5.5, but these are your new data. Okay, you take off the 1 and you take off the 10. 10% trim on both sides. Okay, so shifting gears a little bit, this is talking about variability. It's useful to know the center of your data, but it might not give you a complete picture. Here's two data sets that look very different. Even though their means are not too far apart, the spread is very different. Okay, so that's an important thing to know. There are a few measures of variability that we use. One is the range. This is the simplest formula. It's just the max value minus the min. The standard deviation is a very common measure of variability that's used. You can kind of think of it as the average distance from the mean. It's not exactly that, because if you actually compute the average distance from the mean for each of the values, then you have some positives and negatives, and they actually cancel each other out to make 0. So you have to do this little trick where you square the differences from the mean. Here's x minus x bar, and then square those, and then you sum them all up, and then you take the square root at the end to kind of control for that inflation that you just did of squaring those differences. Okay. Now, important to note is that there are two formulas. Okay, there's standard deviation of a sample, standard deviation of a population. They have two different formulas, and they will give you different results. They also have two different formulas in Excel. Okay. You might be curious about the n-1. We won't go into that a whole lot, but it's important for a sample, because if you have a small sample, then this will impact the standard deviation to a much greater extent than if it's a large sample. You know, if you have an n of 3, n-1 is a huge hit. If you have an n of 5,000, then n-1 doesn't matter that much. Okay. Box and whisker plots. These are a common way to visualize data. They have 5 numbers that they display. It's called the 5-number summary. You got the max, the min, the median, and then these upper and lower quartiles. I'll explain what those are. So the median is the number at which you slice your data in half. Quartile is where you slice it to give a quarter. Okay, so it's kind of the median of the upper half and the median of the lower half. There are actually 2 methods for calculating the quartiles. One is including the median in the count, and the other is excluding it. In the slides, you'll see that I walk you kind of through this manually with Socrative questions. Just know that there are 2 separate formulas in Excel. One is quartile.inc, the other is quartile.exe, corresponding to those 2, and I will specify which one you should use, okay, because they will give you different results. Okay, so for example, here's the median using, this is a data set here, and here's the median using the exclusive method. We don't include the median, which is here at position 10. We look at the middle of these top 9 values, and that gives us the one at position 5, which is 12. Okay. Outliers. These are, we talk about these as just, extreme points. There's a formula in the context of statistics that you use to determine whether a value is considered an outlier. And the convention is to actually put outliers in a dot separate from a box and whisker plot. You don't extend the whisker all the way out to it. You kind of extend the whisker out a little ways and then put the dot there. Okay, so this is the value Q3. You compute the quartile and then add 1.5 times the IQR. That's a threshold that you just computed. If you get a value that's higher than that result, then it's an outlier. Or, sorry, this should be low value. If the low value is less than Q1 minus 1.5 times the IQR, then that's a low outlier. IQR is interquartile range. That's just the Q3 minus the Q1. Okay, and the other thing here is that the percentage of the data in the box here is 50%. That'll kind of relate to the 68, 95, 99.7 rule that we talk about later on. Okay.